Hello and welcome to 3.4 systems with three variables, x, y, and z. So now we have an ordered triple instead of an ordered pair, which means we are going to have three equations and three unknowns. So the first thing we're going to do is we are going to write this system as a linear system in two variables by eliminating the same variable twice. So the first thing I'm going to do is I'm going to label these A, B, and C. And then we are going to decide which variable we want to eliminate. And it looks like I'm going to choose x. So I'm going to take equation A and equation C because they look like the x's cancel out nicely. And I'm going to set them up and eliminate their x's and add the rest of the equations together. So negative x and x, that cancels. Y plus 2y is 3y. 2z plus 3z is 5z. And 2 plus 2 is 4. So that's one 2 by 2 system that I want. I want to find my other 2 by 2 system by eliminating the same variable again. So remember I chose to eliminate the x's, so I want to eliminate the x's again. I'm going to take equation A and equation B this time, and I'm going to multiply equation A by 2. So negative 2x plus 2y plus 4z equals 4. And I'm going to bring down equation B. And I'm going to add those two equations up. When I do that, my x's cancel. I'm left with 3y plus 3z equals 0. And now I have two equations, two unknowns. And when I do that, I can go to the next step. So my next step is taking those two equations, two unknowns, and solving them for the y and the z. So in order to use elimination on these two equations, I need to multiply the top equation by negative 1. So I'm going to multiply the top equation by negative 1. And then I'm going to add them up. And when I do that, this time my y's cancel out. And I'm left with negative 2z equals negative 4. Divide by negative 2. And z will equal 2. Okay, that'll be one variable that I have found. Now I'm going to find the other variable, which is the y that you see up there. So I'm going to plug z back up into one of those equations and find my y. 3y plus 10 equals 4. Subtract 10 on both sides. 3y equals negative 6. Divide both sides by 3, and I get y equals negative 2. Now, just to be on the safe side, I'm going to go ahead and plug it into the other equation just to make sure that my two variables here that I did find are accurate. So I'm going to take 3 times negative 2 plus 3 times 2, and I'm going to check to make sure that equals 0, and negative 6 plus 6 does equal 0. So those two equations, or two variables, do work for those two equations, so hopefully we are on the right track. And now that we have a z and a y, I need to find my x. So the third step is to substitute the two variables back into the original equations to find your x. So now that I know that my y is negative 2 and my z is 2, I'm going to go ahead and put it back into equation 1 and find out what x is. So negative x minus 2 plus 4 equals 2. Negative 2 plus 4 is 2, and that equals 2. Subtract 2, and negative x equals 0. Divide by negative 1, and x equals 0. So now if I know what x, y, and z is, I need to write that as an ordered triple. And, oops, it's negative 2, positive 2. Make sure I put x, y, and then z. Okay. And what I'm going to do now is I'm going to make sure that ordered triple works in all the equations. Now I checked it in the first equation because that's where I came up with the 0. So I already know that it works there, but I'm just going to show all my steps here just so you can see that I am checking. So I'm going to plug 0, -2, and 2 into the top equation and see if that equals 2. 0 minus 2 plus 2 is 2, so 2 equals 2. So it does work in the first equation, which I already knew it was going to. Now let's check it in the second one, which is B. We already know it works in A. Now let's make sure it works in B. So 2 times 0 is 0, minus 2 minus 2, does that equal -4? And -4 does equal -4. So that does check. And now I'm going to check it in C as well because it's not a true solution unless it works in all three of the equations. 0 minus 4 plus 6 equals 2. Does that really equal 2? And 6 minus 4 is 2. And so 2 does equal 2. So now that it works in all three equations, I would say that is the ordered triple that works for the 3x3 system. And that is how you solve a 3x3. Thanks.